All right, so let's go ahead and get started. Again, want to thank everybody for coming today. Thanks for taking the time out of your Friday to be with us and kind of go over some of the machining extension features that Fusion 360 is offering. Um, my name is Umair, work with NextGen CAM. A little bit about me. My experience is as a machinist. I've been using Fusion 360 for about 5 to 6 years now. Um, I've had a good experience with the software. Um, a lot of things can be done with it, especially looking from a simple 3-axis to basic 3-axis toolpaths all the way to complicated 5-axis toolpaths as well. What I really like about it is it's an integrated CAD CAM system too. So it's not only you don't only get CAM features, you also get the CAD features in it as well. And so today we'll be looking more on the CAM things and especially the things kind of more related to machining extension stuff. So let's go ahead and get started and kind of delve into why, how we can use our machining extension for Fusion 360. So looking at some of the benefits, so really what you get with the Fusion 360 machining extension package is the ability to simplify and automate your CAM programming. So especially if you have situations where you feel like you're doing a lot of repetitive things, especially drilling toolpaths to a part that has multiple different holes, and trying to cut down a lot of that time where you keep switching back and forth between a lot of things. The extension offers you a couple of those capabilities that we can look at it today. It also helps you produce better quality parts. So what you get with that is you get access to a lot of different features and different toolpaths that can fit a variety of different parts depending on its complexity. So for example, if you had very organic parts and you needed a full 5-axis toolpath, you get that with the extension. You also have the ability to use a lot of the inspection features on there as well. So the inspection features, if you have a probe fitted with the machine, you can use those to actually set up probing features where you can go ahead and import those values from your machine and then have it actually imported back into Fusion to see what the difference is between the machine and the nominal. We'll dive into that a little bit here on the webinar. And then finally, I want to kind of talk about, the ability to do all these things while also keeping the cost very low. So giving you that added benefit of being able to explore all these advanced features with a pretty good price point, right? So as you may already know, we did this earlier as well. We had a little bit of a video come out earlier talking about how Fusion 360 changed some of their features. So we have a lot of features moving from the base Fusion 360 to the machining extension. And that gives you what's happening here is they're trying to give you the ability to really focus on either you want to use a lot of just the base Fusion 360 features, and then you can upgrade to the machining extension if you're looking for more advanced features. And with this upgrade, like I was saying, you have access to a lot of the more niche products that are offered in the CAM workspace for Fusion 360. And we'll, again, like I said, we'll take a look at a couple of these softwares that the features that moved over to the extension. So as an introduction, we'll start diving into like the toolpaths and stuff. So with our swarfing, what we have here today is a lot of 5-axis toolpaths that were moved onto the machining extension were in 360 base features, but now since we are expecting an array of new full 5-axis features as well, which will be getting added to the extension, it kind of sets the difference between your 3-axis toolpaths and your 5-axis toolpaths. So for example, the Swarf toolpath is a really handy toolpath where you can actually use to cut with the side of your tool, giving you the ability to keep your tool heights shorter, meaning you can reduce the amount of chatter that you get from your tools, especially for people who are looking to cut molds and cavities or dies. it can get a little tricky when you have to extend your tool down about, anything more than 5 inches or so, depending on the diameter of the tool. So using full 5-axis toolpaths like the Warf toolpath can really help navigate through those difficult issues where you have bad surface quality. We also have the multi-axis contour. It's a very good finishing strategy for a lot of parts, especially organic parts that have deep radiuses, deep fillets. Kind of uses the center point of your tool and gives you the ability to give you much better, nicer finishes in those tiny edges across your part. Gives you the ability to blend features between your walls and your floors. You also have the steep and shallow toolpath, which is a really awesome toolpath because primarily when we had our 3D contour toolpath and a scallop toolpath, we would do these two toolpaths separately, meaning you would have to finish off a lot of your walls using the 3D contour, and then you would have a separate toolpath called a scallop or a flat or horizontal toolpath that kind of did more of the floors and the shallower areas. And you would have to do them separately, and you would have to find a way to blend those two toolpaths together. But now with the steep and shallow, you actually get a lot more options on how you want to apply those features, and gives you the ability to get more control on how you want to blend your shallow and steep areas. And then we also have the rotary toolpath. The rotary toolpath is a 4-axis toolpath here that's really useful for a lot of round parts, especially if you want to do, and you can have this toolpath go between either radially or across the part, opting for different sort of finishes. So these are just some of the highlighted toolpaths that we'll be taking a look at today. So I'm going to jump over to Fusion actually right now, just to give you a little bit of information regarding how these different toolpaths apply. So I'm going to go ahead and share my Fusion screen here. Again, like I said earlier, if you guys have any questions regarding the toolpaths or some of the features, feel free to go ahead and put it in the question box, and I'll try to get to them as I go along here. So so this is just a sample part that I have. It's a headlamp mold for auto company. So as I've started a steep and shallow toolpath, as you can see. But then if you look under your 3D and your multi-axis, you have the ability to look at all the different types of 5-axis toolpaths that we have. Like I talked about earlier, we have our Warf toolpath, multi-axis toolpath, and the rotary toolpath. What I really want to kind of delve into today is first primarily is a steep and shallow toolpath. This is like I said, this is an all-encompassing toolpath. For example, because earlier how we used to do it was we'd use a simple 3D contour toolpath. The 3D contour toolpath would give you the ability to do a lot of the machining, especially down the walls and into these steeper areas. However, when you would come into situations like this where you had to blend it with the shallow toolpath, then you would have a lot of cusps between your steeps and your shallows. So in order to kind of get around that, what we have now is the ability to do that all together with a simple steep and shallow setup. So under your 3D, you can actually find the steep and shallow toolpath up here. So just by go ahead and creating one, I'm just going to go ahead and edit this one just so you can see it. You're asked to basically pick the tool that you would like to use. Typically, a ball mill would be an ideal candidate for this sort of application. You also have the ability to turn on your shaft and holder feature over here. The shaft and holder gives you, you can either do this to avoid collision, or you can also find out if you need detect the right tool length that you need to stick your tool out in case you didn't want to rotate your part. But however, typically when you have the steep and shallow toolpath and you have the multi-axis turned on, it assumes you are trying to turn the part. And then in my geometry tab, I'm really going to keep this very simple just because I want to machine the full area that I have here. I'm just going to have it set to silhouette. And then after that, there are other options on there if you want to control the slope and what are the variations that you would like to avoid or you'd like to cut. At this point in time, what I tell a lot of people is try to keep it very simple. If you don't need to go ahead and restrict the toolpath in its primary stages, you shouldn't. If you see something that you don't need to do, or you'd like to kind of change, then you should come back in and change those. Next thing is our heights. Again, as you can see, very simple. As long as you keep just following the tabs, you should be able to get what you need. So again, with the heights, I'm going to keep it very simple. I'm not going to change a lot of things. I do have the ability to come back later and change the heights or my bottom heights if I need to. I'm just going to keep it at the default values right now. And in the past, this tab is kind of where this toolpath sets itself apart from the contour and the scallop toolpath. So as you can see here, you are given the ability to control your step down values for your steep passes and your step over passes for your scallop passes. Depending on the surface quality that you are looking to get, you can go ahead and change these values to what you need. Like I said as earlier, remove cusps of junctions is a very important feature that you can turn on if you're looking to avoid a lot of those scallops and cusps that you see with your ball mill overlapping between two different toolpaths. So you are also given the ability to turn on your smoothing. For smoothing is a really good feature, and what that does, it helps run a much smoother run on the machine. So as a lot of people who have older machines or older controllers might feel that, you know, advanced toolpaths like this might not really run that well on their machines. But given the ability to have the smoothing turned on, even some of the older machines can run this toolpath pretty smoothly. So I would always recommend we go ahead and keep that smoothing turned on. And you have a couple of different ways to do that. You can have fit arcs turned on or the evenly spaced points. Depending on your need, I would just definitely keep it on fit arcs for a more generalized version of the smoothing. And then with my multi-axis, I can actually go ahead and change this on how I want to control my movement. You can have it set to being vertical or lead and lean, or some of the most famous ones that they have. Some of the ones that a lot of people use nowadays are the ability to put a constant lead for your ball mill, so you get a nicer finish on all your toolpaths. So as you can see, we have our collision avoidance turned on as well. Having this turned on will give the steep and shallow toolpath the ability to turn the table or tilt the table in order to avoid collisions with the holder. You can go ahead and restrict these types of movements as well, depending on the application that you're using. For example, if a certain part, if a part has some really complex geometry and you need to get into some very tight spaces, you can go ahead and limit the tilt and turn on there as well. So as you can see, you get a lot of freedom to kind of you know, apply this toolpath to very specific areas of your part as well. And then finally, with my linking, the default values seem pretty good, so I'm not going to go ahead and change anything in there. I'm going to go ahead and hit OK. It's telling me that my machine is the spindle speed is a little too fast for the machine that I have selected, but that's okay. As you can see here, I'm getting an error for something, so I'm just going to go ahead and see what the problem we have here. So it looks like I might have to turn a couple of things off here, and we'll give it a little bit of a try. Let's say okay here, turn my collision avoidance off. Hit okay. So while that's actually loading, I'm going to go ahead and try to show you in my current setup, we now have the ability to actually select machines for simulation purposes as well. So if you wanted to see, right now I have this selected for a Haas UMC 750. We have access to a number of different machines that are part of our database for Fusion 360 and Autodesk database. We have specific machines that are meant only for simulation. And so right now, since I have it on my Haas UMC 750, we should be able to see this, the machine simulation as part of the toolpath simulation. You can also go ahead and change where your part is lined up on your machine. So right now, as you can see, I have it kind of stuck right to the table. Depending on your fixtures and your jigs, you can go ahead and move that and control that and move it wherever it is on your table. We'll go ahead and keep it on there for now. Go ahead, hit OK. Now, as you can see, we do have that steep and shallow toolpath that has been turned on here for us. So I'm going to go ahead and try to simulate this so you can see what this toolpath looks like. And now with the ability to see how the machine is with, so it looks like we have a little bit of a collision there. So I'm going to go ahead and see if I can get it to turn here. Okay, so yes. Well, while that's updating, let's go ahead and see what we have. Okay, let's see if I can simulate that now. See if it turns. As you can see here, the ability to be able to see it with turning with the machine as well gives you a lot more confidence to make sure that you're not crashing into your part anywhere. As you can see, you get a full machine simulation as well. Unfortunately, we don't have the ability to stop the machine as far as any machine crashes. So that meaning I can't know for sure if my spindle is crashing into the part. However, if we have an issue with the tool crashing into the part, I can go ahead and see that, and I can actually have it stop on any sort of collisions there. So it's a really cool toolpath that gives you, like I was saying, the ability to go from steeps to shallows all at once without having to worry about blending in these areas here. Because like I was saying, traditionally, without the steep and shallow, you would actually have to form separate 3D contour toolpaths and a 3D scalp toolpath or a shallow toolpath, and having to worry about how you would blend that all in together. Okay. So that being said, let's go ahead and take a look at a swarfing toolpath now. I have this chain cover right here. It's another toolpath that I have. Let's see. As you can see here, I also have this machine turned on just for ease of access. So with my Warf toolpath, what I can actually do is in my 5-axis toolpaths, I can go ahead and select any sort of tool that I need to. And then typically what we really can do is we can either drive our toolpath with faces or contour chains. So what I'm going to do here is I'm actually going to go ahead and pick contour pairs or do a manual. And then all I need to do is give it a chain that I wanted to follow. And the next step, what I need to do is give it a driving chain that keeps the tool center on that location. Then I can also go ahead and decide where my heights want to be. So I'm going to actually go ahead and increase this up just so that I don't want to cut past that point right there. You can also decide if you want to do this in a single pass, multiple passes. So sometimes I do it from the top, and then I can decide how much step downs I want to do here. So I'll go ahead and just give it maybe about 300s for my step downs. And again, depending on the quality that you like, in surface quality that you're expecting, you can go ahead and change that step down value to something that's preferable. With that, you can also have multi-axis turned on, giving it a sideways tilt and restricting it. I'm going to go ahead and just hit OK just so that I can see what sort of a toolpath I get. And as you can see, I do get my angle toolpath right here. Let's go ahead and simulate that now just so we can see what that looks like on my machine. Might need to go ahead and let's go ahead and change the stock here just so you can kind of see what's going on. I'm going to put it from solid so we don't have any stock there left over. So generate that one more time. Now let's go ahead and simulate that. As you can see, it's going to follow that chain while being able to come in and cut it at an angle. So this would be considered a full 5-axis toolpath. So the Warf toolpath really helps you kind of, if you wanted to avoid doing multiple depths of 3D contours, and if you wanted to avoid keep longer tools that hit the holder, it gives you the ability to keep the tool shorter and go ahead and cut all the way down any sort of walls using the side of the tool. You can all cut all the way down to the bottom as well and keep this radius on there if you're using something like a ball mill or a bull nose, any sort of radius tool. The next thing I wanted to show you was the Rotary Toolpath, which is also available on the extension. So as you can see, I've gone ahead and kind of made this toolpath here, but I'm going to go ahead and hit edit. This is also available under the multi-axis toolpath in the rotary feature here. So I'm going to go ahead and edit this. As you can see, I've just chosen a simple 3/8 ball mill. I'm avoiding cutting the square part. I'm kind of concentrating just on this features right here. So instead of having to worry about coming down and keeping a really long tool and cutting this on this axis, I can actually use my table now as a 4th axis. And then all I need to do is pick the geometry where I want to start cutting from. As you can see, I've restricted it, cutting it from starting from here all the way to the back. What's also nice is you can set angular limits if you'd like to. So if you didn't want to cut all the way around and you only wanted to cut a certain amount, so for example, I can also just say, specify an end angle. I can say it starts from 0 and only does half the part for a 180. Let's go ahead and take a look and see what this looks like. In my passes tab, I can go ahead and adjust the step over for the quality that I'm looking for. I can also go ahead and change the types of passes that I'm doing. So instead of doing spirals, I can even do line and circular, but a spiral is probably going to be your most smoothest transition from path to path. And I would definitely recommend using the spiral pass ability. You can also, again, like I was saying, you can turn on that smoothing option, giving a much nicer, smoother run on your machine and avoiding any sort of jagged movements. You can turn the collision avoidance here on again. I'm going to go ahead and turn this off, but as you can see, by turning that on, if this was on a fixture or a vise, or it was getting too close to the table, you can go ahead and turn this on. So it gives you the ability to have the holder recognize the fixture and then avoid any sort of toolpaths getting too close to that fixture or table. I'm going to go ahead and hit OK here. Seems I seem to have an error here containing it. So I'm going to go ahead and just deselect that, hit OK, see what this looks like. Okay, so it looks like I have a bit of an issue here. What it was saying was basically I couldn't set an angular limit to it. So if I turn that off, as you can see, it went ahead and regenerated that for me. So we can take a look at it now. I'm going to go ahead and say simulate this so we can see what this toolpath looks like. It's going to be very similar to something that you would see on your lathe, a simple 4-axis toolpath. So you can see it's going to work its way all the way through, right to the bottom. Giving you a very nice finish on all your radiuses and all these curved features right here. So if you were somebody looking for an option that, you know, a good 4th axis operation, I would definitely recommend the Rotary Toolpath. It gets pretty much a really nice surface all around. You don't have to worry about seeing any sort of contact marks coming down in your Z because you're having that full spiral toolpath going, starting all the way from top to bottom. All right. So now that we kind of spent a little bit of time on the toolpaths, what I'd really like to also show you is the ability to do the, what you also get is this interactive control wheel for tool orientation. So even if you wanted to do a lot of 3-axis toolpaths, so given any sort of 2D contours or 2D pockets, you would technically have to pick a face, or you would have to actually construct geometry to reference your new Z. But now with the ability to use an interactive control wheel on there, you can go ahead and skip all those as well. So let's go ahead and take a look at that. I'm going to jump over back into Fusion here, and I'm going to bring up this part just so we can see it. So as you can see, I just have a a simple bracket looking part here, and I want to do a, let's just say that I wanted to do a 3+2 positional toolpath right on here and cut that edge, right? So what I can do is I can do a simple 2D pocket or 2D contour. Let's go ahead and do a pocket. I'm going to go ahead and pick a tool here very quickly. I'm just going to use a simple 1/4" flat end mill. Now, the difference that you're going to see today is in the past, you would actually have to pick a tool on here if I had to pick a face. So now with the ability to actually use the tilt control, even on my 3D toolpath, let's say I go ahead and do a parallel toolpath on here instead of a 2D. So I'm going to go ahead and do that same thing. I'm just going to go ahead and use a 1/4" flat end mill. And then as you can see, if I turn my tool orientation on, I now have the ability to use this tilt control wheel here that you get with the machining extension. I can also use this with a face as well. So as you can see, I did give it a reference face for my Z. And now if I still wanted to change my X direction, I have the ability to do that just by using the wheel. If anytime you lose it, you can always refresh it. I can have the tool come in different directions, keeping my Z constant, but having my X come in different directions. So let's go ahead and see what that toolpath looks like now. I'm going to go ahead and say passes. We don't have to do much anything else first. So I'm going to go ahead and hit OK. And then as you can see, since I didn't give it a proper boundary, we're having some issues there. So I'm going to go ahead and say selection for my chain. Say we only want to concentrate on this point. Again, like I said, we can go ahead and change the turn at any time. As you can see, using these rules now, I can have that either flat, not. Go ahead and hit OK. As you can see, now we can convert all these 3+2 positional toolpaths into giving us the ability and the freedom to change our tilt and turn as necessary. Without the tilt and turn control, you would actually technically have to build a plane or offset different planes and create a variety of different reference geometry to do what the new tilt control wheel can do. Again, just kind of automating everything and making things a little bit more convenient as far as selecting your tilt and turn for these 3+2 positional mill toolpaths. So with that, we also have the ability now to do a lot of toolpath modifications. This has been something that's been asked for by a lot of machinists in the past, the ability to be able to just delete tools or toolpaths or trim toolpaths, just so you're not wasting time trying to cutting air, right? So let's just see what this looks on Fusion here. I'm going to go ahead and turn it back on here. So as you can see, we had our steep and shallow toolpath that we just used. For example, let's just say that we wanted to avoid a certain area, right? Let's just say that we had a toe clamp here holding our part down. The toolpath that we wanted is perfect. However, we just wanted to avoid a certain area, but have everything else kind of stay on there. So very simply now in our modification tab that you'll see, if you do have the machining extension, we have the ability to either trim passes, delete passes. We can also change move entry positions and replace a tool. These are all really cool features just to have, because if you just want the convenience to do a very quick edit on a toolpath instead of having to re-strategize and using multiple different toolpaths to get what you need, you can go ahead and use these features. So for example, I'm going to go ahead and trim this toolpath here just to show in case if I did have some sort of a work holding fixture in this certain area and I wanted to avoid this area, all I have to do is click on the trim and I can draw a polygon. I'm going to go ahead and just do a simple square here. As you can see, it gives us a preview shadow of what that looks like and tells us, do you want to keep the toolpaths on the outside, the inside, or both? Typically what you want to do is to keep it on the outside, meaning that all the toolpaths on the outside of the polygon will stay and everything else will get deleted. So let's go ahead and see what that looks like now. I'm just going to go ahead and hit OK. Then as you can see, it went ahead and avoided that whole region where we used our trim toolpath. We can also go ahead and do delete passes as well. So let's take a look at what that looks like. So simply by clicking on the toolpath that you want to edit, go ahead and drop the menu down, select your delete passes. And if I wanted to delete passes in certain areas, so for example, let's just say I didn't really want this toolpath right here that's coming and doing these arcs, I can simply click on toolpaths and hit OK now. Then as you can see, it went ahead and deleted those toolpaths without taking the time to either regenerate or having to re-pick any sort of boundaries or put any sort of slope restrictions on it. So you get a very quick and easy way to edit these toolpaths now, making it much faster to move, for programming purposes. Again, like I said, if I wanted to, for example, move, let's go back to that initial Warf toolpath that we made right here. If I wanted to go ahead and say, I didn't really want my toolpath to start from this point, and I wanted to start, for example, from here, I can go ahead and say modify and move my entry position. Oh, I forgot to pick on my toolpath. So that's one thing that you need to do is you need to click the toolpath or select the toolpath that you want to modify first. And I'm going to go ahead and say move my entry position. Simply by clicking and drawing a line here all the way to the end, it highlights all the paths that need to be changed, and I can go ahead and hit OK. Then as you can see, it moved my starting locations and my exit locations to this point. Again, making it very simple, very easy to change those. These are not features that you have available to you if you don't have the extension. All right, so let's go ahead and touch on a little bit more on the inspection features that are now available to you on with Fusion 360 machining extension. If I wanted to go ahead and find out if I am close to machining or if I'm still out of tolerance with this part, I can simply go ahead and use my inspection features that are available to me now. So under my probing, if I go ahead and do a simple inspect surface, go ahead and select a probe here. Just going to go ahead and select a generic probe. As you can see, I just need to give it a quick feed rate here. And now, just by clicking on certain positions, for example, here or at the bottom here, and you can have X amount of positions picked on here. And all I can go ahead and say actions. And if in case the probe is out of position, meaning that if it hits a point that it doesn't recognize a stock being there, it'll immediately stall the machine, basically protecting your probe. At this point, what I can do is go ahead and hit OK. And now what I can do at this point is I can actually go ahead and say, if I needed to post this out using my post for example, for like a Haas machine, I would have a Haas inspection post. I can go ahead and post this program out, run this program, and after it runs the program, the machine controller is going to spit out a file for you with the actual geometric positions. What I can do after that is I can actually bring those by importing those inspection results. I don't have a file right now available to me, but I can go ahead and import one off of either I can upload it to Fusion or I can select it from my computer. I can bring those values in here and then I can relate that to my actual CAD geometry. And after I hit OK, it'll give me an inspection report stating that, well, this point and this point compared to my actual CAD data could be either in tolerance or out of tolerance. So this really helps speed up the process of trying to do a lot of manual inspection. It also helps with the ability to cut down time if you had to move the part over to a CMM or something like that to get accurate results, it can assist with doing a lot of in-machine probing before you actually take the part out. So this is also available in the machining extension as well. Finally, what I'd also like to show you is some of the automation features that's available with the machining extension. In order to do this, I'm going to go back to my headlight mode here. Like I discussed earlier, we also have the option now, if you have the machining extension, you have the hole recognition feature. As you can see, there's multiple different holes on here. In order for me to create a simple drilling operation, I can only do that on a single. If it's on the same axis, I can go ahead and do that. So just to kind of show you the difference, I'm going to go ahead and say select. Let's start off with probably maybe a 1/4" drill or something that's similar here. And I can go ahead and pick my hole. And then as you can see, if I hit same select size diameter, I'll only get the ones that are on that same plane, right? So in order for me to go ahead and touch on each of these different hole axes, I'm going to have to create multiple different drilling toolpaths, which is probably a really long time. It's going to have, it's going to give you a lot of issues with programming. So instead of that, what I can now go and do is use the hole recognition feature. And by using the hole recognition feature, it's going to study the model and look for all the holes. And it's going to give you this report stating, well, I can spot and drill these holes, or you can even just change it to, you know, spot drilling and tapping these 2 holes. So it gives you the ability to change those things as well. So as you can see, if I go ahead and hit OK now, very simple and very fast. I haven't changed the drill size for these drills, because you can also go ahead and change where these what tools you're actually going to be using. So right now it's pulling my tools from my sample tool library, but if you had a local library, you can go ahead and pick all your tools from your local library to be used for the drilling operation. You can also go ahead and, so you can change those diameters as you please. But now, as you can see, in a couple of clicks, we already got everything programmed on the top. But again, I don't have the holes on the side. The neat feature about that is that anytime I can go ahead and edit this now. In my options, I can actually say, I want to use my multi-axis machining as well on here. And now if I go back to my hole groups, you can see I have a whole bunch of different holes that are now being recognized, and that's going to be all these side holes. So as I was saying, you can go ahead and change the drill size at any time, depending on the library that you're pulling from. I'm going to go ahead and hit OK, just so you can see now that instead of us having to go ahead and do them individually and select different axes for all the different tool orientations, Fusion 360 gives us the ability to use the hole recognition feature, and within a couple of clicks, just basically go ahead and have all the drill points programmed for me. I gotta say, that's a pretty handy feature to have, especially because for me to do this individually, that's going to be quite a lot of time put towards my programming. So just to kind of recap here, let's take a look. So some of the primary features that you get with the machining extension is the ability to do the automation on there. So with like I said, showed you earlier, with the hole recognition feature, drilling and tapping holes now could be a breeze. Instead of doing them manually from hole to hole for different tool orientations and different tool axes, we can have within a couple of clicks, within a couple of mouse clicks, we can go ahead and actually program a whole part and all the different hole sizes that you have. And this works for a number of different tools. You can have the ability to do countersinks with these, different taps with these. The next thing like I showed earlier, was our 3+2 position milling with our tilt control wheel now. If we didn't have the tilt control that you have with the machining extension, you would have to spend a lot of time going between your CAD side and your CAM side to go ahead and construct a lot of reference geometry. So these could be anything from constructing surfaces, constructing planes, axes, just to be able to give more freedom for your tool to be oriented. So instead of doing all of that now, you can just simply have a tilt control wheel available to you, and you can go ahead and change it change the freedom of degrees on how you want your tool to be entering your part. And then we have our 5-axis and 4-axis toolpaths that I kind of showed you. So that covers everything from our Warf, the steep and shallow, rotary, and all these different toolpaths are available now with the machining extension. Gives you the ability to have better quality parts, better quality 5-axis toolpaths, and all in all, just giving you a better machining experience from having to do multiple setups. Now you can go ahead and do multiple different features on your part, all with the simple ability of like a steep and shallow toolpath. And then finally, as you saw, we had our toolpath modification. Gives you the ability to really speed up the processing time for going ahead and editing toolpaths. So instead of doing sketch geometries or creating boundaries, you can simply, within a couple of clicks, go ahead and change your entry positions. You can avoid certain regions, especially for fixturing purposes. I can see this being really handy in the molding and die world. And then you can go ahead and just delete passes as well, giving you the ability to really control your tool paths and giving you the confidence, to make sure that your tool isn't going to be hitting any sort of hitting the part in any way. What I also want to say on top of that is you can use the machine simulation available to you as well to give you a lot more confidence on how your program is going to go. With that, I want to just mention we have with NextGen CAM, we have our e-store, which makes purchasing very simple. If you need the ability to go ahead and purchase these the extension. Let's see, I have a quick question here. It says, can you use hole recognition for hole-based milling operations? Currently, unfortunately not. You can only use these for just drilling operations. However, if you are looking for something like a hole-based operation, circular bore thread mill, in that case, a patterning option would be really helpful. If you're looking to do the same operation, but in multiple different locations. I hope I answered that question. Yes, currently it's restricted just to drilling operations. So that can be anything from drilling, tapping, reaming, any sort of hole operations. With that, I'd like to open the floor for more questions. Feel free to contact us at any time too, if you'd like to get more information regarding what the machining extension can do for you, for your specific needs. But other than that, that's kind of all I had to cover today. Go ahead and I'll keep the channel open here for some questions.